All right. Hi, everyone. My name is Daniel. I'm working also at SUSE, and I'm working mostly of the time on nvme-fabrics stuff, topics, and one of those things involves like user tooling. And when I submitted my talk, I was very like, oh, what can I show nicely and cool thing? And I said, okay, let's look at this thing, fabrics, if it can scale. So that was one of those things I wanted to try out anyway. So, but then we could just look at the bright side of our life and go for a beer. No? Okay. Anyway. So one thing I try to do is basically when you have a host and target and the target exposes lots of namespaces, what will happen? So we have this userland tool, nvme-cli, which has this command connect all, and the connect all command does exactly what the name says. It tries to connect all namespaces it's discovering and then shows us, basically sets up the whole system. So if you have NVMe TCP, so the NVMe transport protocol is capsulated in a TCP connection and passed over to the target side. And in this particular case, we have a setup with a multipath. That means we have 4 TCP connections, and we go through every connection to other side and connect to the other endpoint. And this command for 200 namespaces took roughly half a second to do the connection. And then obviously at one point you want disconnect, and this takes like 38 seconds. And that's okay. Is that a problem? I don't know. Some customers for them, they seem to care that the disconnect is also fast, but why would you ever want to disconnect anyway? One thing which you should note here is that the connect and the disconnect command are synchronous. That means userland initiates the connect by writing a string, a magic string, into a device file, and when the write returns, the operation has been done. And you get also error message or error codes back if it fails. And if that operation is successful, you get the device name which was created back, or the name, the node ID back. So what you don't know at this point, before you do the connect, you don't know which device you will get. That's an important thing to remember for later. Anyway, so this is for NVMe TCP. So Fiber Channel is very loved by the community. And so I tried to do it with Fiber Channel. And the thing is, first, obviously, you have a very complicated string. You need to how to address the other side. And the connection takes 800 milliseconds. And the disconnect is in the same range, like 740 seconds. But what you have to remember, see here, is that the connect actually is asynchronous, meaning it returns immediately. The magic string is written into the device, and it returns immediately. And then you have in that particular case, it took roughly 100 seconds until the system stabilized. So there was like much of action happen in the background, in the kernel. And discovery log page open, yeah, exactly. Let me put that away. So, so there happened lots of things during that time, and the thing is, obviously, during that time, also the system, if you look at it, will show you something in between, right? It's not so cool anyway. So now, not so fast. So that was when I was like, okay, this is a good topic to present. But then I thought like, yeah, it's probably too much work to fix all that stuff. Let's do something else. Well, it's kind of related. So for Fiber Channel, so what you have to know now, what I want to look at is basically how userland does all this in the operating system, so how it's integrated that things automatically connect. For example, if you boot up your system, or I mean, the usual thing, right? You want to plug in something and it gets set up correctly. So in the fiber channel case, and that's important to know, it's just for fiber channel. For TCP, it's completely different. We have the kernel, which will announce a discovery controller on the fiber channel, over the fiber channel. Why is that possible? Fiber channel has a built-in kind of discovering layer. So you don't have to do any yellow pages or synchronization daemons, whatever. You get that from fiber channel itself. And that's why basically the kernel and the driver layer can announce to the user land, okay, there's something on the other side, you want to talk to that, maybe. And that's a U event. So we have a UDEF rule, which intercepts that message, or that event. And what it does is it parses the environment variables and encodes them as string argument, or the argument in the systemd unit file. So you have lots of encoding problems there already, because this has to be working over the shell environment. And the command line gets really, really, really long. You saw already the previous slide when this is basically all those stuff will be encoded in the arguments in the file name. So that's pretty much a long string. And then this unit file, basically what it does, it uses the arguments as nvme connect all arguments. So what does connect all do? Any question? Has anyone an idea what connect all should do? Yes, everyone has a different opinion what it should do. Some want, yeah, it should connect only the fiber channel things it found. But some devices on the market, they show you everything they have on the discovery page. So you get the TCP connections listed, you get the fiber channel connection listed. Yeah, what does connect all do now? Fun. So I thought like, yeah, that's not really cool. And as I said, this works for fiber channel. For TCP, actually, we don't have anything currently in upstream. There is a project, it's from Dell, which basically turns the whole thing here, the UDEF stuff, in a daemon. And they have a listener which listens on TCP, multicast for the announcement, basically. There is something to connect to. And yeah, so basically they built and demonized everything. Said, okay, what they can do, I can do as well. So this is, or before we get to that page, let's have a fast one. So this is the test setup we had, for example. And so you have a target, you have a switch, and you have the host. Everything has 4 paths connected, and we have a chaos monkey going wild. That means it will tear down the different connections. So it tears down one connection, waits for a minute or whatever, tears another one, brings the first one back, you know, that stuff. In the end, there is always a connection, but you have never a stable system, which is a test which is obviously you want to make for your enterprise expensive hardware stuff. And we had a lot of bug reports that eventually the system got stopped working, completely stopped working. And it was a lot of debugging and looking at starting to print case stuff in the kernel, annotating systemd, udefd, and everything to figure out what was happening. So what you see here is on the x-axis is the udef sequence number. Basically, it's the time. And the y-axis is the time it takes from the UDEF event issued from the kernel until this udef rule is executed. And you see that we are in the range of 10 seconds delay sometimes. And that's the stable situation. That's when it worked. And eventually we had, so this is the 10-second thing here, and eventually it exploded and we had 2 minutes, 3 minutes delays until the udef rule was executed. And what that meant is basically we had from the kernel an event which said, okay, something has changed, execute connect all again. So every time you see that point, nvme connect, execute. And that was, nvme connect means I'm gonna do a full discovery of the other side, read everything back, and connect to everything once again. So it's a heavy execution. You have no idea when things are executed. You have no plan what's happening. So that was, and interesting enough, this is not probably a bug, it was a bug. It's now fixed in udef upstream. It took a while to figure that out, but still, yeah, not so happy about that. So let's do something else. To recap, this design currently is kind of fire forget. You have no idea when things are really executed, you have no tracing. nvme connect means different things to different people. There's no right, no wrong. We have no reconnect logic at all or tracing. The current solution upstream has no support for TCP discovering at all. And what's also worse, we have absolutely no way to interact with anything else on the system. So it's like a global resource, we own it, you can't do anything else with it. And we have also kind of no way to figure out when you use a block device, which connection serves that block device. So it's very easy to type nvme disconnect all and everything is gone. You wipe out your system. Especially if your root file system is nvme TCP, which is yeah, please.
So the no reconnect logic, does that actually mean that you disconnect all and reconnect, or does it mean that you try to reconnect all connections and might override an old connection?
Okay, I have to make that more precise. So there is a reconnect logic inside the kernel.
Okay.
What I mean with this is basically the reconnect on the initial connection. Yeah. So if we write our magic code string. If that fails,
it never does it again.
Yeah.
Okay. No, I understand.
And that, for example,
no retry.
Yeah. So, for example, that could happen if you have an unstable setup and you do the TCP connect and it says address not available or not found. Then nothing happens. Connect all is fire and forget.
Yeah.
So yeah. Obviously, we want to do something else. So we have the same thing as before. So that's a proposal. I've prototyped that stuff to figure out if it actually would work. And to my pleasure, I had the chance to talk to Leonard during LSFM. And he didn't shoot me on the spot. So I kind of got an approval for the idea. He had lots to say in the details, but the big picture is here important. So the details, we might do something else or differently, but the design idea is basically, so we still have the kernel for Fiber Channel sending out the new event, and there will be an active component, it's nvme discovery D, okay, which handles the U events, and it will also support like listening to or the TCP part as well, for example, or RDMA. And what it will do is it will create unit files. And then in the unit files itself, basically we have, okay, let me step back. So the unit files basically are written for every connection we want to make. So there's not one connection unit file for which will call connect all. Instead, we have for every connection we want to make one unit file. And in the unit file itself, we have just a connect, not a connect all. So it's very specific. I want just this connection and only that connection. And as I said, I did some prototyping. So this is now the discover D output, as you see. What it does basically, it's discovering the other side in that case, and the red part is where it's writing these unit files. So these files are landing on the run. Where did I put it? Yeah, in the run folder from system D, and then in this prototype I had to reload it. So Leonard gave me the tip, you can do it differently so that you don't have to reload the driver. System D daemon, I have to figure out how that works in detail. But interesting, basically the main thing here is, so we have now two unit files which describe the connection. Then the next step, okay, yeah, here's the unit file. So we have the usual stuff at the beginning, and then we have really just nvme. Sorry, the font is a bit dark. Sorry about that. Anyway, so you have the connect call and the arguments listed directly. What I did here is, as you can see, it's of type simple, and it starts. And I've extended this command so that it will stay as daemon. The reason for this is it should disconnect if you kill it. So that basically when you start the unit file, it initiates the connection, and if you stop the unit file, it will shut down the connection. I had to keep the state. So for this, the simplest thing was basically just keep it running, and if you kill it, it will just call disconnect for this thing. But it doesn't need to be like this. We could also make nvme disconnect a bit smarter so that you can pass in the arguments. So this is the kind of things we can play with and figure out what makes more sense.
And you could also have a watchdog that restarts it if it crashes and so on, if there's a problem.
Exactly. So the thing is, obviously we can do now reconnects on the connect. If we have like address failure or transient errors, we can react on that one. And so the very good, the thing I really like is now that we can actually have per connection logs. And this is for, if you're a sysadmin, whatever, you like to have this kind of separation. You can just see what's happening. You can also obviously say the state of the service. So if you have system control, you list off and you see, okay, this connection is not working, you see it. You can look into the log files and you see it. And what I did here, because if it was already a daemon, we could probably do something more with it. And I just said, okay, let's listen for the U event for the controller, which is, and if you have, for example, a reconnect or remove thing, you get that in that unit or this nvme connect call, you can monitor that currently. I mean, there's nothing added to it yet. It's possible. It was just to play a bit around and see if it makes sense or not. And obviously we could also make this attached to something else, whatever, but basically there's some playground. And as I said, the logging is very cool because now it's even permanent over boot time. And you see like the state when you boot, if you shut down and reconnect, you see that stuff. So you have a kind of insight into the system, what is happening. And yeah, there's nothing really, usual stuff you would expect basically, right? So that's the plan for the future. And before I can do that, I have to do the 3.0 release of the nvme-cli tool. So the reason for this is simple. 5 years ago or 6 years ago, we did the initial release of nvme-cli 2 with the library libnvme version 1. We're stupid, we should have used version 2 and 2. But to make life difficult, let's make it difficult. nvme-cli 3 is basically the result of we got the library API a bit not perfect. So, and there was like we collected a lot of like technical debt over the time, and so the plan for to address basically that thing started the project version 3, and just to show you why we have this technical debt, until version 0.7, nvme-cli just implemented the NVMe specification as command, so to the PCI device, and that was, you can see a few thousand lines of code, maybe 10,000 lines of code at that point. The spec grow over time, so if you would just implement that part, it would be like 3 times. But most of the stuff here is the result of nvme-fabrics. Yes, the fun part. So the goal of the 3.0 release is basically, yeah, let's fix the APIs where we had stupid ideas, and don't try to break user land in the sense of the use of the nvme-cli tool. So we don't rename commands or have a new argument or change argument names or so. Basically, if you use nvme-cli, it should be the same thing with version 3. Not that many new features were planned, but suddenly life happens, so we have a few new things coming along. And as I said, we're going to break the library interface, basically. And at the Alps conference last year, I got a lot of great feedback on how to model the new API. So we had to turn it left to right and up and down, and now everybody is hopefully happy. It was a lot of work. So that's a good plan, but basically, there are the few sections we worked on. So on the core part of the library and also nvme-cli is that we centralize the whole fabrics code into the library. So the whole logic is now in the library, because before it was split between 2 parts and had very awkward APIs between the library and nvme-cli. As said, the whole command marshalling interface has changed, and there were people asking for making the API also a bit more readable, because we use the nvme prefix for everything, for the commands and for library functions, and the spec people basically said, we're really confused, this function doesn't exist in specification, what you're doing here? And said, oh, that's not in the specification, it's a library function, it's nothing for you. And so what we've done there is basically make it more clear what is specification, things, and what is library functionality, and so on. I thought initially, so, oh, well, it's a lot of work, but I was surprised. It was very easy, thanks to large language models, and renaming APIs actually is not a pain anymore. So this was like a 10,000 line change, 10 minutes work, and I was not going insane. So that was a big win. Then what we also did is, for example, the error handling changed, because the POSIX error handling is weird, and we found, I would say, 20 different bugs where we just didn't handle the error at all or incorrectly. So now we return error codes always inline, makes it easier to use, and we have now also negative errors or internal errors, such allocation errors type. If positive numbers is transport are protocol errors. So you can basically look at the return value. If it's 0, everything is good. Anything else, you know what happened. And that makes it a bit easier to use. Then we had, after the versions 1.0 release of the library, we had a submission for supporting nvme-me, that's this management interface part of the specification. And one thing that the trouble with that MI stuff is it's a different transport type. And we didn't have any abstraction for transport. That means our commands, any command we had was just expecting that you have a file descriptor and you can just work on that one. And MI is going through different channels, like you can send nvme commands over, what's the bus, I2C and some things like that. So you can, it's used for if you have a BMC, and a big machine, and you can basically talk to the NVMe device from the BMC domain to that one and send commands back and forth, which is obviously neat. And but that transport is not a socket or a file descriptor. You have a socket actually on Linux. So didn't work that well. And we had lots of workarounds in the API that work, that stuff still works, so that you have your normal nvme command was sent over the other channel, basically, or transport. And so we have introduced a kind of transport handle. We have now a global context, which means if you, which all resources, if you start up and allocate or start the library, basically, you get a global you create a global context for example, logging, so that if you want to log, you get the chance that you can intercept all the log messages and either write it to standard out or just ignore it, whatever. And we have the same for on transport layer. We have a transport handle, so we can attach stuff there. And the funny thing about that is, in the version 1, someone posted patches for supporting I/O uring, because he found out that when he does get log pages with that interface, it's like 20% faster for him. So, and that was like, yeah, okay, but what the patch was doing is if you call get log pages, it created the uring, registered it, executed the command, closed the ring, and removed everything. For every time you use get log pages. Very inefficient, and the feedback for the community was like, what are you doing? It's like, yeah, that's stupid, I know. Very stupid. And now with the global context, we have a way basically to create the uring once and use it everywhere and afterwards, right? So that makes it more flexible. And I thought like, yeah, no one will use it until I remembered that the author of the MI support was saying, I really want to have asynchronous support for commands so that I can send several commands and wait on different commands, because one command might take very long to execute, something like format or whatever. Thus, having a synchronous interface for every command is stupid, especially if a very slow link. And so I thought like, oh, I/O uring could be useful here. So now I'm working on making that interface actually useful. So we have asynchronous support as well. So that's why when I said I didn't want to add new features, but now we're gaining features a lot because we cleaned up the stuff and it's usable now. One thing we also did is we have a lot of getter-setter functions, and writing them is boring. We have now a Python code which generates them from the C code. So, and we have also a Python binding for the library. And thanks to the LLMs, it's now actually Pythonic. That means before that it was written, it was used like a C code, and now you write it really, you can use it as you would expect if you write Python. So all that stuff works. While we're working on that, we also made, for example, the feature set, the library and the nvme-cli supports more compile time configurable, so you can enable stuff and disable stuff. One of the reasons I've started to do that is one vendor came along and said, hey, we like your tool. Could we port that to Windows? I said, yes, I don't know, show me code. And so we started working on that, and that was the config to be able to configure the options what you want to have in the build was basically the enabler. So we disabled, for example, for the Windows build, all the Fabric stuff. They don't get that. I don't know if they support it, but currently there's no Fabrics for Windows in plan. And then we start to clean up the header files once again and move stuff around and make it more usable. And actually, this push to support Windows basically forces us to rethink where the code is, in which file it lives, which header file it includes. It cleans up the code base quite a bit. And I just saw that we got a pull request yesterday for enabling the final pieces on the library. And just to give you the idea, the Linux part to pass through a command in userland to the kernel is using ioctls, obviously. And we have like a couple of functions in there, and that was 250 lines of code. The Windows part, 1,700. It's fun. I don't have to maintain that part. I will not touch that stuff. Alongside, because all those pushes come now to support this stuff, we have started to improve our game with testing. So the CI build, we have nightly CI runs thanks to Dennis working hard on that thing. We enabled the end-to-end tests, we were already there, but no one used it so far. So we have its nightly run. We actually have the commands you type on the command line and execute them against real hardware. Have a coverage, which command is actually executing which part of the code base. I've re-enabled the Coverity report. Unfortunately, it just was told that Coverity pulled the plug. They're rebuilding their data center. So all dashboards for the open source projects are currently down. No idea if they bring it back, but currently Coverity is currently not available. And I spent time enabling it. That's annoying. And one thing I also did was the end-to-end tests in nvme-cli. They work against the QEMU implementation of the NVMe controller. And that's very cool because now I can tell our QA team that they just can use our test suite to test if the package is correctly built. So it makes my life a bit easier that I don't have to maintain all or I have to tell our QA team how to test. I can just tell you, run the test suite, which we have upstream. And also people are starting to provide new test cases, so it's a big win. Yeah, so I'm way too fast, but I think someone in the audience is happy, yes? New bike day. Okay, one of the other thing what happened is NVMe Top. So NVMe Top, this is the idea that we need more insight what's happening inside the system. And this is now for a single path device. But let me show you the live version. Oh, nope. So this is that disk here in this machine. So we have only a single path NVMe PCI device. So this is the controller. You see the controller here, and above is the namespace, and you should have the same numbers if something happens, and some static information on top, obviously, and then you have the dynamic parts below. And the very cool thing is you can scroll. So you can go back, for example, if you have more stuff here. So this is the subsystem view, and then you can just go in, and they have this stuff. I mean, it's what you would expect, right? It's nothing fancy about that. The interesting part is actually if we have a multipath setup, then you would see on the controller side, you see the different paths at the same time. You see, for example, which path uses more bandwidth, if you have imbalance or something, or you use an I/O scheduler, which does, for example, just use one path instead of several. And you look, I mean, people will then understand why they have not the performance, or they have a problem. Currently, you just see the reset and errors counters here. The Nile, who's working on that stuff, wants to add additional information like failover rate or error counters, stuff which helps you to understand why stuff doesn't work. And that's now in. So that was 2 weeks ago when I gave the presentation. It didn't exist yet, and then now we have it, so we're moving fast. And I like it. I hope we can add some more colors. Anyway, plans here are to also provide the Grafana board so that we have long time statistics. And while we are doing this, I thought, like, let's add an MCP support. So we can hook up an LLM and figure out if, when things go wrong, maybe pointing, okay, here you have increased latency, and then things go south situation, and it could point you where to look. That would be a kind of support case, helpful, I guess. Not sure if it works. This is more experimental. So, but that's what we try to do. Go away. Where I am. Yeah, and then one idea I had was maybe for, to collect like your configuration in the sense of if something goes wrong or not working correctly, that we have upstream tool to basically say, okay, you have timeout settings which do not work with each other. For example, if you have a command, I/O command timeout, which is shorter than your read time timeout, things are not working as you expect, probably. So that's something probably gonna do. Let's see how that works. But this is the end of the presentation. So if you have any questions or suggestions, I'm open to it. Thank you.
I wonder a little bit why you did the generate new service files for systemd. It feels like it should be a little bit more like systemd network D, where you can see the devices connected and then you can select which one you want to connect to. But you would have something like a at target or a configuration thing. Because like if you so I understand that the command line is very big as well.
Yeah.
So it feels like you want something that collects all the possible targets you can connect to.
Yes.
And then you want to have a smaller name that you can refer to that device with, and then you say that I want to start this one with this referral to the device, and then you get the connection for that thing, because you might want to connect to all things or none of the things, or just some of the things.
Yes, yes.
So just that it auto-generates the service files seems a little bit odd to me.
Yeah. So what you're targeting towards is basically have influence what is
what is connected. So you could have like a default policy that says connect to everything you find, and then a system administrator can say that I'm only interested in these things on this machine.
Yeah. So.
But it might be connected to more.
So. Good point. So what I was thinking is, we moved all the connection or all the fabrics code into the library.
Yeah.
And I want to clean that stuff up and also make it add hooks into that stuff, decision hooks basically. Yeah. And with the Python binding, basically, if you drop in a Python code and you get like, okay, do you want to connect or create the...
But I'm thinking from the systemd perspective, as you're booting up, as it is now, it would create service files for all the possible connections. And I'm also just thinking about people moving things around, and then you have like a large stack of service files that are outdated and might start on boot.
Yeah, I mean, in the end...
it would also be cool to have some kind of CTL where you can actually see which remote disks or devices you have and see which ones are connected and get the status of reconnecting. And
okay, what it didn't mention is what we can do with the generated service files. There's a possibility to kind of add a forward dependency to the block device thing. So when the block device appears, basically the block device knows.
Yeah, so it gets mounted when it's seen.
Yeah, it belongs to that service file.
Yeah, okay.
And then if you have a file system on top, whatever, and you would try to disconnect that service or shut down that service, systemd would say you can't.
Yeah.
But that will only work for very trivial cases. If you start putting stuff on other things, that doesn't work that well.
No.
And also what I was basically unaware until I talked to Leonard is for the root file system, that's not the mechanism we're going to use. It's completely outside of systemd. That means in the pre-boot environment, I think they call it, you would have a shell script what exactly does that thing. And the thing is, by creating those var files, we can also create kind of ownership files, which means this connection was created for the root file system, and these connections were created with with the discovering service. And if you type in your nvme connects something on the shell, then that's owned by the user.
Yeah,
and if you
differentiate,
exactly. And then if you do nvme disconnect, it will obviously first pick just the user stuff and leave the other things away. If you don't want that, we could just add force and say YOLA.
Or just kill with SIGINT.
Yeah. And the reason for the idea with the state files basically is also if we crash, we can reread the state, and we can also use nvme-cli without a daemon. Yeah. So we don't need a daemon for this, and if we have a third-party component trying to do something, it can look into there and figure out if we can use it or not. Yeah. So as I said, it's still playtime.
It's very difficult, but it still feels a little bit more like a systemd network D inspired thing would be. We can take it.
Yeah, I have to look at that stuff to really understand. I can't really comment right now.
No, I understand.
Yeah, any more questions? Maybe we have time for one final one. No? All right, thanks.
Thank you.